Hey, what's up guys? In this video, I'm going to show you how to construct a confidence interval using the TI-84 graphing calculator. So in other words, I'm going to show you guys how to find those values for the confidence interval. So the problem that I have here, it says researchers collected data on the NOx levels in grams per mile. So NOx is just the pollution that cars give out. So it's carbon monoxide and everything else. So that's what they called it, NOx, for a random sample of 40 light-duty engines of the same type. The mean NOx reading was 1.2675, and the standard deviation was 0.3332. Now, first, we need to understand that this is a one random sample of 40 light-duty engines of the same type. So we have one sample. In that sample, the mean for that reading, for that sample, was 1.2675, and the standard deviation is 0.3332. So we want to construct a 95% confidence interval for the mean of the NOx emitted by light-duty engines of this type. So when you guys are writing your response for constructing a confidence interval, there are some steps, 4 or 5 steps that you guys need to do. I'm not going to do all the steps. I'm just going to show you guys how to use the calculator. But remember that you guys do have to state your parameter. You guys have to check your conditions. You guys have to plan what method you're going to use to find the confidence interval. You have to do the work, and then you guys write your conclusion. But in the calculator, let's go ahead and look into that. What functions you need to use to find the interval. So first, I like to write what I know. So I know from this information, my sample mean X bar, and that is my statistic. My statistic X bar is 1.2675. The standard deviation of the sample, and notice I'm using S, not sigma. S is for the sample, which is your statistic, is 0.3332. So right here, and my sample size is 40. So when you guys are using the graphing calculator, make sure you guys know what confidence interval you're using. So here we are using one sample because we just have a random sample, and we're looking for the means. Since we are using the sample standard deviation S, that means that we have to use a t distribution. When you guys have sigma, the standard deviation of the population, you guys can use z-scores, z as in Zorro. We are going to use the t distribution because we are going to have to use the standard deviation of the sample. So we go to the calculator. You guys go to stats right there. We have test over here, and there's many options, but the one you guys need to look for is for intervals. The first set is going to be test. So we're not using test. We go down to intervals. So we do have a z interval, t interval, 2 sample z interval, 1 sample t interval, and then you guys have proportions. So 1 proportion, 2 proportions. We're not using proportions. We are looking for the true, or we're estimating the true mean. So not proportions. And we do have 1 sample, not 2 samples. So I need to use the t distribution because we're using S of x, the standard deviation of the sample. So we go here, and you guys have 2 options. If you have the data, meaning that you have the readings, all engines, and there's 40 different engines. If we had that data, we need to put that data in the list 1, and then when we go here, we can use data, and the calculator will construct the confidence interval. But we don't have the data. We have statistics, meaning that we have this statistic, X bar, and this statistic, the sample standard deviation. So we're going to use stats right here. My X bar is 1.2675. My S of x, the standard deviation of the sample, 0.3332. Sample size is 40, and be careful with the confidence level. We are constructing a 95%, so 0.95. You always use decimals, and then you guys calculate. So the interval is right here. inside the parentheses, remember this is not an ordered pair, it's just the interval for the true mean of the population. So it is between 1.1609 and 1.3741. So let me write that down right here. So we have 1.1609, comma, and 1.3741. Now I do want to emphasize on the conclusion. Just because you guys have the numbers, you're not done. You guys have to conclude, you have to write your response in context of the problem. So I'm going to show you guys the last step. There's many steps. Remember that you guys have to check your conditions, you have to state the parameter, you have to do the work, and then you guys have to write what method you're going to use. But the conclusion, after you find this interval, we say we are 95% confident that the interval from, and I have those values, 1.1609 to 1.3741, captures the true mean. And I'm going to underline the word true mean, mu, so there's my parameter. That is for the population. So the true mean amount of NOx emitted by light-duty engines of this type. So what it means, all the values between those two numbers are plausible values. We don't know what mu is exactly, but we know that is between those two numbers. How confident are we? We are 95% confident. So every time you guys use the calculator, it will give you the problem will give you guys a confidence level. So make sure you guys know what confidence level you guys are using, and then you guys use the calculator to find those values. But you also have to interpret or write your conclusion in context of the problem. So this concludes my video. If you guys like my videos, you guys can click that like button, and you guys can also subscribe to my channel. Make sure you guys practice, and I'll see you guys later.